When you think about any food delivery app, the first thing it asks would be the user's current location where the food needs to be delivered. In this section, you're going to learn how to get the user's locations properly. In that process, you will be learning how to create a brand new Vue component and the route for it, HTML5 Geolocation API, Geocoding API, Autocomplete API, and much more. By the end of this section, you will have a fully functional app that does this, getting the current location when a user gives permission to a locator. If the permission is denied or the locator gives a wrong address for some reason, users can still be able to enter their addresses manually, just typing in it like so. Also, you have noticed that I have changed default style of the drop-down addresses. I'm very excited to show you building this app start to finish. Let's get started with the next lesson when you are ready. Vue.js is a front-end framework and it's component-based, similar to Angular and React. But it's very popular amongst developers because it's very simple to use. Let's see how to install and get started with Vue. The first step is to install Node.js and npm Node Package Manager to your computer. You can check to see if they are already installed by going to the terminal window and run node space -v and npm space -v. If they are not installed, head over to Node.js website and choose the LTS version to start downloading it. Then install it to your computer as usual. Now we have Node.js and npm installed. And in my case, I already installed them both, and the Node version is version 12.13.1 and the npm version is 6.13.4 at the time of this recording. You may have a higher version by the time you are watching this video. There are multiple ways to install a Vue.js project in my computer. Let's see how to do it using Vue CLI. Vue CLI is an npm package that allows us to create a Vue project quickly by asking a series of questions to configure our project the way we want it, such as do I need a router included, how I want to build the Vue app, and so on. Let's install it globally so that I can create a Vue project anywhere in my computer. Open up the terminal window and run npm space install space vue-cli. And to install it globally, add -g at the end and hit enter. This will take a few seconds to complete the installation process. Once it's done, the next step is to create a brand new Vue project. I'm going to create it inside my desktop. So on my terminal window, I'm going to say cd space ~/desktop. Then run this command, vue space init space webpack. Project name, my first project. The name must be URL friendly, so no space. At this stage, you may be asked to install CLI init package. If so, go ahead and install it by running the following command, npm space install space -g space @vue/cli-init. Once it's done, you can run the vue init webpack command again. This will ask a series of questions. The first one is project name. The project description I'm going to leave as it is, and author as well. Vue build. I'm going to choose the runtime plus compiler recommended for most users option. Then I'll be using Vue router in this course, so I'm going to say yes to it. I'm going to say no to ESLint, unit test, or Nightwatch. Then it will ask how I want to install the dependencies. So I'm going to choose npm install. This will take a few seconds to complete the installation process, and it will show you with two commands at the end. The first one is to go into the project directory, and the second one is to run the Vue project, which will start the server and run the Vue app on it. Rather than using it from the command line, I'm going to open up the project on the Visual Studio Code editor by dragging the project folder and drop it off into the Visual Studio Code icon in the dock. The good thing about Visual Studio, it has an inbuilt terminal. So go to terminal, new window. As you can see, it's already inside the project. Run the app using the npm run dev command. This will start the server and give you the localhost URL. Copy that and switch back to the browser, paste it on the browser. Excellent. Now we have our first Vue app up and running. Let's explore the folder structure. If you look at the folder structure, you can see the node modules folder that contains the installed npm packages. Then src folder. This contains the source files for our project. I'll be doing most of the work inside this folder. The assets folder contains the project assets such as images or any other file that will be imported into the components. Then the components folder. This contains the Vue components that are not main views or pages. When we repeat a set of code in multiple places in our project, that code would be a separate component created in this folder. Then the router. This is where you're going to create a route and attach that route to a Vue-based component. We will learn more about the file structure and how to organize them later in this chapter. In order to use any of the Google Maps API services, we need to obtain an API key from the Google Cloud Console website. In this lecture, you're going to learn how to create an API key, then how to enable billings, as the API keys do not work without that. After that, I'll be showing you how to protect the API key as it can be exposed to the users. Finally, you're going to learn how to enable different Google Maps libraries. I'm very excited to show you them all. Let's get started. Let's go ahead and open up the Google Cloud Console website on the browser. So console.cloud.google.com. It will ask you to log in with your Gmail account. As you can see, I am already logged in, so it takes me straight to the Google Cloud Platform dashboard. In order to create an API key, we need to create a project first. To create a new project, go to the top and choose Select a Project drop-down menu. It opens up a project window where you can see the existing projects, and I have one project here. Okay, at the top right, create a new project by clicking the New Project button. Then give it a project name, and the location is no organization for now. It's good. And hit create. This will take a few seconds setting up this project. Once it's done, you can go to the project by clicking the link from the notification icon at the top right, or you can go to the Select Project drop-down menu at the top and choose the project that we want to create an API key for. Once the project is selected, it will take you to the project dashboard. Next, let's create an API key in there. So go to the top left bar button, then choose API and Services option from the sidebar and choose Credentials. Then click Create Credentials and choose API Key and done. This is the API key that you will need throughout this course. Okay, now we have an API key, but without billing enabled, this API key won't work when we are making a request to the Google Maps API. Let's see how to set up billing next. Go to the sidebar and Billing, choose Manage Billing Account and choose Add Billing Account. Select your country and select the terms and conditions. As you can see, Google gives a $300 credit for free at the time of this recording. And it's more than enough to complete all the project in this course without paying for this service. Click next, then choose the account type, then address, then add your credit card information and hit start my free trial. Once billing is enabled, you're all set to go. Billing is based on number of HTTP requests that we are making to the Google Maps API. So we need to protect the API key so that no one is actually making an HTTP request with our API key. As you can see, there is a warning icon before the API key name. That means this key is not fully safe. Let's see why it is not safe. In my case, I'll be using this API key inside the Vue components in some projects, and it will be exposed to the client. That means anyone can open up the source code on the browser and be able to find this API key. Then they'll be able to make a whole bunch of HTTP requests with this key, which is no good. That is also called quota theft. Luckily, we can protect our API keys by allowing HTTP requests that are only coming from a specific domain. In this case, your own domain. Let's see how to do that. Click on the name of the API key. Then, inside the applications restrictions section, choose HTTP referrers. Then come down to the website restrictions and click on add item to add your domain. In my case, softauthor.com, and choose done. We can also restrict the API key to give permission a specific maps library. Okay, hit save, and now you can see a green check circle indicating that the API key is safe. Nice. I will be using different Google Maps libraries throughout this course, such as Google Geocoding API, Places API, and so on. By default, the libraries are not enabled. We will need to enable them as we need them. Let me show you how to enable Places API, for example. Go to the library from the left bar and you can see all the available Google Maps API libraries. I'm going to choose Places API and hit the enable button at the top. Then go to the APIs option and you can see the Places API under enabled APIs section. If you look at the project folder structure, there is a source folder that has a few folders and files in it. The components folder is the place normally Vue component files are created, but I'm going to create a new folder called pages under source directory and creating user location component there. By right-clicking the source folder and choose the new folder, then I'm going to call it pages. Here is the quick difference about when to create a new component inside pages folder and the components folder. Think about when your component is going to take a whole page on the browser, also be attached to a route such as /login/home. In that case, you create a component inside pages folder. On the other hand, whenever you have a piece of code that is repeated more than one page-based component or repeated multiple times inside a single page-based component, which is the indication that piece of code can be a separate reusable component created inside the components folder. For example, navigation bar, buttons, input fields. Okay, in this case, I'm going to create a page-based component. So select page folder, then right-click on it to create a new file called userlocation.vue. As you can see, I use title case, which is the common best practice when naming a Vue component. Inside the user location Vue component, let's create a template tag, which is where all the HTML code lives inside a single div container. I'm going to create h1 element and say user location page inside it, like so. Now we have a simple page-based view component is ready. But how are we going to view this component on the browser? Well, a route needs to be set to this component like /home or /about, so that when a user enters any specific route, the component which is attached to the route would be visible on the browser. To attach the home route to the user location view component, head over to the route folder, and it has an index.js file. Inside the index.js file, for every new route, you will be adding an object which should have at least two properties inside the route array. Path. The value of the path is the URL that user typed on the address bar when visiting your app. The second property, component. The value of this property would be the name that you give when importing Vue file that you want to attach to this route. As you can see, it's already set to Hello World Vue component for the home route. Let's get rid of that object. I'm going to create a new route object by creating opening and closing curly braces. The first property would be the path, all lowercase with a colon. The value would be / in between quotes, which is the default route. This is the route you would go first when running the application. The second property is component, and set its value to the user location.view component that I have created earlier. At this stage, index.js route file does not know about the user location component, so I need to import it at the top. Import user location. This is the name that you would include as a value of the component property inside the route object. From here's where I would need to specify the location of the component. In my case, inside quotes, @ which takes me to the source directory /pages /user location. As you can see, I did not add the .vue extension at the end, as Vue files are inferred with .vue automatically, which is very handy. Let's run it by opening up the terminal and going to the project using cd space your project folder name, then run npm run dev command. Nice. One more thing I'm going to do here is to remove Vue logo. To do that, go to app.vue file, get rid of image tag, which is above the router view directive, as well as clear the style, and hit save. Hop over to the browser, and now the logo is gone. At this stage, we have successfully created a user location component and assign it to the home route. In the next lesson, let's create this beautiful UI design inside user location.vue file using a CSS framework called Semantic UI. Welcome to another lecture. In this lesson, I'll be showing you how to use Semantic UI to build our simple but beautiful user location app. The first thing is to link the Semantic UI CSS file to our project. I'm going to be using CDN format, which means the link I'm about to get was hosted on the Semantic UI website. So let's go and grab that. Open up the browser, go to Semantic UI website, and click the menu icon. At the top left, choose Getting Started link from the sidebar. Under Preface Using Build Tool section, click the recipe link at the end, which will bring another page. Half the way down, you can find the Semantic CSS link under Single Component section, at least at the time of this recording. Copy the first link that has CSS extension, then head over to our project and open up the index.html file. and paste the link between the head tags like so and hit save. Go to user location Vue component and I'm going to change the container element from h1 to section element. This is where I'm going to write all my HTML code. Okay, let's see the design. The first thing I want to do is to create a container element and center it on the browser. To do that, I'm going to be adding class attribute to the section tag with a few semantic UI classes, which are UI 2-column grid. Yes, I'm making a 2-column grid wrapper here, and I will let you know why just in a moment. Then declare 2 divs inside it with a class name column and give different colors class names for each div so that we can see them on the browser. But what I want is 1 column and center, right? For that, all I have to do is to get rid of one of the columns and add centered class to the 2-column wrapper element. That will give a nice centered box. Wait, why would I need the class 2 still? Well, if you want to change the width of the box, all you have to do is to play around with that class. For example, change it to 1 from 2 if you want to make the box to be full width. Alright, I'm going to get rid of the red class for the column div that I have added it before to show you where the div actually is and how much space it takes. Time to create a form tag with a class UI space segment space large space form inside the column div. In there will be 3 visible elements, which are the error message box at the top, the actual input field with the locator button on the right, and the go button. Let's take a look at one by one. First, error message. Create a div with a class name UI message red. UI is a common class that you use all the UI elements that are visible on the browser, and the message class puts the rounded corner border to the div, and the red is the background color as well as the border color. Pretty straightforward. Next one is the input field. Let's create a wrapper for that first, starting with div that has 2 classes, UI and segment. Segment class is also very similar to the message class, adding a rounded corner border to the element. Create another div with the class name field, which is an input group container. Inside it, I'm going to define another div with a few semantic class names: UI, right, icon, input, large. The right icon classes will put the icon on the right side of the input field. So let's declare the input field and the icon in there. Input type is set to text, and the placeholder attribute is set to enter your address, like so. Under that, create I element with a few class names: dot, circle, icon. These will tell what type of icon and how that should be displayed. For more icon options, you can take a look at this page. The last element is the go button, which is pretty straightforward. Create a button element with a class name UI button and add text go in there. Perfect. One more thing that I'm going to do is change the button color so that it matches my theme. To do that, create a style element after the end of the template tag, like so. Inside that, define .ui.button and opening and closing curly braces. I'm going to change the background color and the actual text color of it. So background -color colon, and its value would be # FF5A HTML5F, which is reddish pink color, I think, and the text color will be white. I will do the same to the icon classes by adding a comma and typing dot 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 circle dot icon without any space in between. Awesome! Now you know how easy it is to build this beautiful form with a few semantic UI classes. Now I am ready to get user location when a user presses the locator icon, which is right side of the input field. That is exactly what I will cover in the next lesson. Welcome back. In this lesson, I'm going to be talking about HTML5 geolocation, how to get latitude and longitude from this geolocation API. HTML5 geolocation is a browser-based API which basically lets us to get user location in the form of coordinates, which are latitude and longitude. Here is the chart that shows which browser and its version supports this geolocation API. One thing worth pointing out here is Google Chrome version 50 or above is only enabling this API when using HTTPS connection. However, it works fine in localhost, which is exactly where I'll be testing this. Let's see how to add a click event handler to the locator button. All I have to do here is add a click event handler called locator button pressed in the locator icon, which is an I element. In Vue, you would create all the event handlers callback functions inside method object, which is the standard best practice. Let's go and do that in action. Open up userLocation.Vue component. After the end quote, hit space and add sign, click equal opening and closing quotes. I'm going to call it locator button pressed. Now declare this callback function inside methods object. To do that, create script element in between template and style elements, like so. Inside that, type export default opening and closing curly braces. This is where all of the JavaScript code would go into. Let's create a methods object here. Inside that, declare locator button pressed function. The first thing I want to do inside the function is to check if the geolocation API is supported by the user's browser using navigator.geolocation object, so that we can tell a user that your browser is not supported, so please enter your address manually using the Autocomplete API, which I will cover later in this chapter. Let's do that next. Inside the locator button pressed callback function, if navigator dot geolocation is set, all good, else I'm going to console log your browser does not support geolocation API and semicolon at the end. I will cover how to handle all errors, including this one, in a separate lesson again later in this chapter. Moving on, to get the geographical position, all you have to do is to call getCurrentPosition method. This takes 3 arguments. The first one is the success function, and the second one is the error function, and the third one is an options object. The way it works is when a getCurrentPosition is called, a browser notification window will appear close to the URL bar on the browser, and as the user, in my case localhost, wants to know your location, if allow button is pressed, the getCurrentPosition method will return the coordinate object to the success function specified in the parameter called position. On the other hand, when the block button is pressed, error function will be invoked and returned object specified in the error parameter. Inside the if block, invoke getCurrentPosition method and semicolon. In between the parentheses, declare the first argument, which is success error function with a parameter position, in which we can get latitude and longitude coordinates. I'm going to console log them. Console.log, opening and closing parentheses, position.coords.latitude, and console.log, opening and closing parentheses, position.coords.longitude. Let's declare the second argument, which is error function, console.log, opening and closing parentheses, error.message. Save the file and switch back to the browser. Open up the developer console if you haven't already by right-clicking the browser and select inspect. I'm going to click the locator button. The notification window pops up. Choose allow, and you can see the latitude and longitude coordinates printed in the console. Let's see if the error message works as expected by blocking the location. I'm going to click the locator button again, but this time the notification does not show up. Why? This is because I have already gave permission to the browser to get my location. To reset it, in Chrome, click on the eye icon, which is before the address bar. Change the location option from allow to ask and reload the page. Let's try it again. This time I'm going to choose block option, and you can see the error message appear in the developer console. The next step is to convert these coordinates to an actual human readable mailing address using Google's Geocoding API, which is exactly I'm going to cover in the next lesson. I'll see you there. In this lecture, I'm going to be showing you how to get an actual address using Geocoding API by making an HTTP request using AJAX. So what is Google's Geocoding API? Well, geocoding is the process of converting street address to geographic coordinates, which are latitude and longitude. But what we want is the opposite, right? So what we need is a reverse geocoding, which is basically converting geographic coordinates to an actual human readable street address. Here is the HTTP endpoint for that. maps.googleapis.com/map/api/geocode/JSON. The last parameter, JSON, is the response format. Along with this, I'm going to pass two query parameters in order to get this working properly, which are lat_long and key. The value of lat_long would be the actual value of latitude and longitude separated by comma, and the value of key parameter would be the API key, which I showed you how to get it from in the previous lesson. I'm going to be using Axios, which is an HTTP client, to make AJAX request. This is going to be a three-step process. Install Axios, import to user location component, and make a request using get method on the Axios object. I'm going to open up the terminal from my Visual Studio Code editor, Vue terminal, and run npm install --save Axios, which will take a few seconds to install it to our project. Let's import Axios module inside user location component. After the script tag, import Axios from Axios inside quotes. Now we have Axios ready to use. Let's declare a function called getAddressFrom with two parameters, lat and long, inside methods object. Then call this function inside where I console log geographic coordinates and pass the latitude and longitude as arguments to that function, like so. In Vue, you would use this keyword when you are calling a function that is declared inside methods object. Okay, in the getAddressFrom function, I'm going to invoke get method on Axios object, like so, and pass the Geocoding HTTP endpoint URL. Inside the codes, maps.googleapis.com/maps API JSON lat long equals. Here I am concatenating lat and long values separated by comma and adding key as a second query parameter using the and sign. The value of the key is your actual Google API key. Axios.get method will return a promise, so add then function which will have a returned object specified in the parameter called response if the request is fulfilled. If not, the catch function will be executed. I'm going to console log the error like that. Inside then function, I'm going to do one more check to see if there is no error message in the response object. For example, if the API key is not valid, the response object will have an error message. Let's check that. If opening and closing parenthesis response dot data dot error underscore message, opening and closing curly braces, inside that I'm going to console log that error. Else, get the actual address using response dot data dot results, which would be an array, but I'm going to get the first index of it, dot formatted underscore address. Let's switch back to the browser, click on the locator button and allow. Indeed, I can see an actual human readable address and it's working great. Let's show the address in the input field. For that, define an instant property called address inside data function in the return object, then bind this address property to the input field using b-model directive, like that. After that, all I have to do is set this property to an actual address that we get from Geocoding API, like that. Let's test that. Nice. We are not done yet. Let's see if the errors are working as expected. Make some changes to the endpoint, maybe adding some text after comma, save the file, switch back to the browser, and you can see request failed with status code 400 in the developer console. As you can see, the line number actually matches, so we know it's coming from the catch function. To check the error message in the response object, make API key invalid by adding some text to it and try that, and it says this time the different error, the provider API key is invalid, which is coming from the then function inside the if error check. In the next lesson, I'll be showing you how to show the errors when it happens on the screen at the top of the error message box. As you can see, the error message box shows regardless at the top of the form. We can simply make it to be visible only when there is an actual error. Okay, let's create a property called error inside the object that was returned by the data function. Set its initial value to an empty string. When the error property contains an empty string, the error message element will be hidden. Otherwise, it will be visible with the error text. Pretty straightforward. So I can easily toggle the error message element by adding a Vue directive called Vue-show to it. Inside the starting tag, equals, double quotes, error. In here, the name error is referring to the property name error here. Then, in between the tags, add the actual error text using double curly braces and the property name. in the locator button pressed function, inside the error function, which is the second argument of get current location, set error message to the error property by adding this dot error equals error, which is an argument up here, dot message. You would need to use this keyword in front of any property which is declared inside the data function, similar to calling a function that was declared in the methods object that we saw in the earlier lesson. In the else statement, do the same. This dot error equals. Let's set the error message inside getAddress from function as well. The first one is inside then function if block. This dot error equals response dot data dot error message, and the last one is inside the catch block. Again, this dot error equals error dot message. That's it. Let's try it out. To get the error message, I'm going to deny the permission. Then the error message element shows up with the text. That's awesome. Sometimes getting user location will take a few seconds depending on various factors such as internet connectivity, user computer speed, and so on. It would be nice if we show the spinner until the user gets an actual address or error message. Luckily, we can add a spinner animation quickly on the right side of the input field using a semantic UI class called loading. Let's take a look at how to implement that. Inside the input container, I'm going to add loading class along with other classes. And you can see the spinner inside the locator button. What I want to do is to add this loading class dynamically whenever there is a delay in getting the user location. So the first, I'm going to get rid of the loading class from the input container, then create a property called spinner inside the data function. This is the property I'm going to use to add or remove the loading class dynamically from the input container and set its initial value to false so that the spinner is not visible by default. Let's add loading class to the input container when the spinner property is true. The way you do is before the end of the starting tag of the input container, add :class equals inside double quotes, add a pair of curly braces. In there, loading :spinner. The first value loading is referring to the class that I want to add it to this element if the second value is true, which is the spinner property. Let's set spinner to true at the top of the located button pressed function. I'm going to say this dot spinner equals true. This way, as soon as the user presses the located button, the spinner becomes visible. Nice. Let's hide the spinner as soon as we get an actual address or error by adding this dot spinner equals false to those places. One more thing worth pointing out here about the error is, let's say whenever the user denies the permission to access the location, you get a message like user denied geolocation. Sometimes it's recommended to use your own error message depending on the situation. In this case, rather than saying user denied geolocation, I'm going to say locator is unable to find your address. Please type your address manually, which will direct the user to what to do next. But we don't have the autocomplete functionality yet, which is what I'm going to cover in the next video. Hey there, welcome back. In this session, I'm going to be showing you how to show suggested addresses in a drop-down list when users start typing their addresses in the input field. This is very useful when a user denies sharing his/her location accidentally, or when the HTML Geolocation API does not support by their browsers. We can easily get this functionality working using autocomplete. First, I'm going to be showing you what autocomplete is and how to use it inside our project. Then you're going to learn how to restrict suggested addresses to a specific region so that users can get their addresses with less typing. Finally, let's have some fun changing the CSS style of the list to match our theme. What is Autocomplete? Autocomplete is Google's library, which is a part of Google's Places library in the Google's Map JavaScript API. The first thing to do is to load the Google Maps API URL before using the Autocomplete library in our project. As you can see, the API URL is generic, so we just need 2 query parameters to add at the end to let the API know that we are using the Autocomplete library. The first query parameter is the library name that we want to use, in this case, Places. As I mentioned earlier, Autocomplete is a part of Places library. The second parameter is the key. Let's see that in action. Go to index.html and inside the head element, create a script tag with a source attribute equals. Inside the quotes, add https://maps.googleapis.com/maps/api/js and question mark libraries equals places, which is the first parameter, then and sign key equals your actual API key that you get it from Google, and the closing script tag. The next thing we want to do is instantiate Autocomplete object. To do that, switch back to user location component, and after the data function, I'm going to create another function called mounted. Mounted, opening and closing parentheses, and opening and closing curly braces. This will be called whenever the DOM is ready. So it's a great place to do any DOM manipulation. Let's instantiate Autocomplete object inside there. New space google.maps.places autocomplete with uppercase A, opening and closing parentheses. It will take a few parameters. The main one is the input DOM element that we want to add the autocomplete functionality into. To do that, I'm going to set an ID attribute called autocomplete to the input field. Then come back here. Inside the parentheses, I'm going to say document.getElementById opening and closing parentheses autocomplete. Let's save the file and run the app. That's great. Let's see how we can show addresses from a specific region close to a user location so that it's easy to find his or her address with minimal typing. For example, I live in Canada, and when I type 1, 2, 3, the suggested addresses are from the US and Taiwan. I can still get my address, but it takes longer. Let's say I want to show Ottawa street addresses first before showing suggestions from other cities or countries. To do that, all we need is the geographic coordinates of the city. In this case, Ottawa. You can find that information by just doing a simple search like Ottawa, Ontario geographic coordinates, and there it is. This is actually DD coordinates, decimal degree, but what I want is a simple standard coordinates. So I'm going to click the first link, and the simple standard is the first option. Now we got that coordinates. To add the coordinates into our project, I would need to pass a JavaScript object as a second parameter when instantiating autocomplete. So after that comma, create an object by opening and closing parentheses and create a property called bounds, and its value is going to be two maps object, lat long bound and an actual lat long. First, instantiate lat long bounds object, new space google dot maps dot lat long bound. Inside the parenthesis, instantiate lat long object. This is where I'm going to add the coordinates new space google dot maps dot lat long opening and closing parenthesis. Inside that, paste the coordinate values separated by comma, like so. Let's switch back to the browser. As you can see, it shows all the auto addresses first, followed by other matching addresses. Nice. Let's change some style to the drop-down list to match our theme. This image shows what CSS classes we need in order to change the list style. I'm going to get rid of the icon on the left side of each address, which is .pack-icon class. Inside the style tag, I'm going to say .pac-icon, opening and closing curly braces. Inside that, display none, semicolon, which will get rid of the icon. And it did. Nice. Let's increase padding to each item. The target CSS class for that would be pack-item. I'm going to give padding 10 pixels to all sides. Then increase the font size of the text to 16 pixels. Let's change the cursor to a pointer, which is the hand symbol. Finally, I'm going to give a hover state for the pack-item class with gray background color. Let's check this. That looks better. As you can see, the city, province, and the country has font size as expected, but not the actual street name. To change the street name font size, we need to use another CSS class named pack-item-query. So, .pack-item-query, opening and closing parentheses. I'm going to set the font size to 16 pixels. Let's try one more time, and it works. There you have it. Hey guys, welcome back. By the end of this lesson, you'll be able to show the user's current location on the map, whether the user gets a location by pressing the locator button or by selecting a specific address from the autocomplete drop-down list. As you can see, the map is in full screen mode behind the form as well. Let's show the user's location on the map when a user clicks the locator button. First, I'm going to add an HTML element that will be used to display Google Maps. So go to the template at the top. After the end of the section tag, define another element called section with an ID attribute and set its value to map. As soon as I add this element, the code editor gives me an error when I mouse over it. It says the template route requires exactly one element. This is because in Vue, there should be only one element which is a parent inside the template tags. All other HTML elements should be only the children of the parent element. To fix that, I'm going to wrap both section elements with the div element like so. And the error has gone away. Let's add some CSS properties. To do that, scroll down to the style element, define a new CSS rule called #map. Inside it, I'm going to set the position property to absolute and set the top, left, right, and bottom properties to 0, which will make sure that the element covers the entire screen. Let's also add the background color to red to see if the HTML element is positioned correctly. Nice, it takes the full width, but it hides the actual form. To bring the form to the front, I am going to add an inline CSS style with a couple of properties to the section element at the top. So go inside the starting section tag. I'm going to say style equals inside double quotes position property colon relative semicolon z index colon 1 semicolon, which will bring the form in front of the map's HTML element. Let's try it out. Nice, it works exactly what we wanted. Next, I'm going to show the Google Maps map object on the screen when a user clicks the locator button and gets the location in the form of latitude and longitude. So I'm going to go inside the locator button pressed function. After the get address from function, call this dot show user location on the map function, which I'm going to declare in a moment and pass the latitude and longitude values as arguments to it. Then go to the methods object and declare show user location on the map function like this, with latitude and longitude parameters like so. This is where I'm going to create a map object and add the user location marker to it. So define the map variable let space map equals new space google.maps.map with m caps opening and closing parentheses. And I'm going to pass two parameters to this constructor. The first one is an HTML element where the map is going to be added to. So document.get element by ID opening and closing parentheses inside double quotes map, comma. The second argument is a JavaScript object in which I'm going to add three properties to it. The first one is zoom and its value is 15, which I think perfect number to show the map, so it's not too far or it's not too close, comma. To center the map based on user's current location, I'm going to use center property and its value would be lat_long object. So create lat_long object new space google.maps.lat_long opening and closing parentheses, then pass the current user's latitude and longitude values to it as parameters. Finally, the map type, which will be roadmap. Map type ID colon google.maps.maptypeid.roadmap. Let's try it. And the map is working great. As you can see, the map is centered based on the user's current location, but there is no marker indicating where the user's actual current location is. Let's add the marker to fix that. So after the map object, define marker object new space google.maps.marker with m caps and opening and closing parentheses. I'm going to pass a JavaScript object with just two parameters in it. The first one is the position property, which tells the marker where to be placed on the map, and the value of the position property will be a lat_long object passing the current user's coordinates like so. The second one is the map property, which tells the marker which map it should be placed into. So I'm going to pass the map object that I have declared above. Let's try it now. And the marker is placed exactly where the user's current location is. Nice. Next, let's see how to show a location on the map when getting a user's address from the autocomplete drop-down list. I am going to attach an event listener called place_change to the autocomplete object. This event will be triggered when a user selects a specific address from the autocomplete drop-down list. So go inside the mounted function and give a name to the autocomplete object. Then attach place changed event listener to it. So autocomplete dot add listener, opening and closing parentheses. This method will take two parameters. The first one is the event name in quotes. So inside double quotes, place_changed. And the second one is a callback function which will be called when the event is complete. I'm going to use an arrow function for that. So comma, opening and closing parenthesis, equals, angle bracket, and opening and closing curly braces. To get the selected place information inside the callback function, invoke the getPlace method on the autocomplete object and assign it to the variable called place. Let's console log this variable to see if it works. Nice. Now all we need from this place object is the latitude and longitude values, so that we can simply call the show user location on the map function that I have already declared and pass the latitude and longitude values to it. So this dot show user location on the map, opening and closing parenthesis, and pass the latitude and longitude values from the place object. So place dot geometry dot location dot lat, which will be a method. So I'm going to use opening and closing parenthesis, comma, place dot geometry dot location dot lng for longitude. Nice. Now if you choose any place from the drop-down list, the map will show the location like a chart. Also, the map will show users' current location when they use the locator button.